you about how we're using perfSONAR for WLCG and a little bit about how we used it also to prepare for the data challenge that we just had last month. Okay, so a little bit about WLCG. Maybe some of you aren't familiar with the high energy physics infrastructure we put together to do our computing. I'll talk a little bit about how we're using perfSONAR in that infrastructure, the data challenges, and then some tools and next steps. So first about the Worldwide LHC Computing Grid, WLCG. So what high energy physics does is we explore the forces of nature and the very small constituents of nature by doing high energy particle collisions and measuring what comes out. It's kind of like throwing two cars together and there's a carburetor and there's a spark plug and there's a motor component, and figuring out how a car works by looking at the pieces. So the largest energy, the highest energy collider that we have is the LHC, the Large Hadron Collider. That's located at CERN in Geneva, Switzerland. And currently the LHC experiments in total are generating hundreds of petabytes a year, and that's going to be going up. We have multiple experiments that operate at the LHC and collaborate on infrastructure for the WLCG. And the WLCG is really the spanning organization to help us manage and utilize that infrastructure. We generate a lot of data. We basically have periods of running and interspersed with long shutdowns where we do upgrades. We're currently at the end of long shutdown 2 and we're preparing for run 3, which will start next spring. The real challenge is going to be in a few years when we get to the high luminosity LHC and run 4, and we're going to start producing exabytes of science data per year. The complexity is going to go up in terms of the events themselves. There'll be 200 overlapping proton-proton collisions. So you have your interesting event with these 200 other background things that happen in the same collision. So it's a real challenge for us to deal with. So we're basically going to have about 10 times as much data and 100 times as many collisions as what we use to find the Higgs boson. All this data and these globally distributed resources require excellent networking, right? We have sites all over the world. When we have these networks that interconnect them, we've actually done quite a bit of work to try and create our own overlay networks or our own personal private networks with the LHCOPN and LHC1 to help us out. This is kind of a map of LHC1, and you can see there's a lot of sites all over the world. These are really just the main points of presence and big wide area network connections between these sites. And we've overlaid where we put strategically some perfSONAR toolkits that we actually can use to help test and understand what's going on in LHC1. Now a little bit about the specific perfSONAR infrastructure we use. Of course, for us, end-to-end network issues have been an ongoing challenge ever since we started the LHC. Network problems are multi-domain. That complicates the process. Nobody owns the whole system. And when we have performance issues, it's really complicated by the number of different components that are involved. So we've observed that network problems really severely impact us on occasion. When you're working with a global infrastructure to do your science, a significant slowdown can impact a lot of people all over the globe. In some cases, finding and fixing problems have taken weeks, months, or even years to get fixed, with hundreds of phone calls and thousands of emails to try and get them resolved. So perfSONAR really gives us a number of standard metrics that we can use. And without this kind of measurement, we wouldn't really have a hope of reliably using these global networks to do our science. So for the last few years, we've been focused on deploying and configuring a global perfSONAR monitoring framework. The little map on this diagram shows sort of the WLCG perfSONAR toolkits that are deployed. We've created this pipeline to manage the toolkit deployments and to gather the data and send it to a number of locations. So what do we have in terms of tools? First, a little bit about the amount of data that we're sending around. We're doing about 65 million tests a day. perfSONAR is, of course, the main fraction of that. We also grab SNMP data from ESNet, and we grab data from job transfers from our HD Condor systems. We're doing about 3.2 terabytes worth of data a year. So it's not that large on the scale of our other data, but it's still a significant amount of data to have to deal with and get value from. In the next few slides, I'll have some examples of how we actually access and visualize the data. Of course, Kibana that was shown earlier is one of the nice tools to just get a feel for what the data looks like. I have a link here that should let you get to our Kibana instance, and you can pick different indices. This shown here is the packet loss that we're measuring, and of course all the documents that Kibana has are visible there, and you can filter and cut on those and have a look around. We also maintain an infrastructure dashboard. We have about 240 active perfSONAR instances, really 207 that are production endpoints that cover our tier 1s and tier 2s. We're continuously testing 5,000 links. We've tried to get each site to provide latency and bandwidth nodes sort of co-located with their storage. And there's a link on here that'll take you to this dashboard. I've only shown you the top of it. There's a lot of different visualizations and information about our global toolkits. We also have dashboards that are specifically focused on the types of data we're getting. So shown below is some of the information from the traceroute Kibana dashboard. We have similar ones for packet loss, throughput, and latency, and all those links can take you to those locations. By the way, the slides will eventually be available for everybody. So I know right now you can't click on these, but later you can grab the slides and look at them. So recently, earlier last month, we had actually a data challenge. So we have some significant requirements for our infrastructure. And as I mentioned, run 4 is going to be our big challenge. Basically, we're going to need more resources than we can afford. And so we're trying to figure out new ways of analyzing and looking at our data to do the same amount of science, maybe with less storage or less compute, right? And so one of the important things is to verify that we can use the infrastructure we currently have effectively. So we planned out a series of data challenges every 2 years. This year it was 10% of high luminosity LHC scale. In 2 years, we should get to 30%. And another 2 years after that, 70%. And finally, in 2027, we should be fully at high luminosity LHC scale. We should start in 2028. So this year, we used perfSONAR to help us identify issues prior to the test and help us fix various firewall and infrastructure problems before we actually tried to push the infrastructure to the limit. The challenge, the so-called network data challenge, was October 4th through the 8th. The goal for 10% of high luminosity LHC was sort of an average of 240 gigabits a second from the tier 0 to the tier 1s and from the tier 1s to the tier 2s. This primarily involved Atlas and CMS, the two big general purpose experiments at the LHC. And what we found was good. We saw that the network itself, in most cases, wasn't the bottleneck. It tended to be issues with the either software, middleware, or end systems that were involved. Of course, we're still doing the analysis and postmortem. There's a lot of data to look at to figure out what actually happened. perfSONAR really is a critical component for us because these tools and the associated dashboards that we have really help us understand what's going on in the infrastructure, where there are bottlenecks, where we have problems. And of course, when issues arise, it's also useful to both identify them and help localize them. So, perfSONAR helps us set baselines for our sites. And so we understand sort of what the current status is, and we can look for changes. We can find bottlenecks, and we can focus on improving those. So our goal is to use perfSONAR between these data challenges to help really understand the infrastructure and where we need to improve it to get ready for the next data challenge. We've developed some new applications along the way that have been used to try to look at all that data we're gathering. One of the requests that we get from a lot of our insights and administrators is really, can you just tell me when there's a problem that I should look at, right? Tell me what the problem is and tell me I should look at it. And while it sounds somewhat simple on the face of it, it's really more challenging than you have to think, because we don't want to alert every user in the whole global networking community about a problem. We only want to tell them about problems that are likely something in their infrastructure that they can fix. So we first have to verify it's really a network problem, not an end site problem, not a storage or server problem, and then try to localize it. Where exactly is the problem? That gives us the best targeted information. And so we've tried to develop an alerting and alarming service to do this. So we have this service running. It's sort of in beta mode. It uses federated identity. Anybody should be able to log in and subscribe. So you can go to the site and actually use your institutional credentials and log in. And we have separately another application called PS-, perfSONAR Dashboard, that has some high-level data analysis and ranking, and it also serves as sort of the test platform to develop alerting for the AAS service. These applications were developed in collaboration with students who've been working on this from the SAN Iris OSG LHC process. And this is what the alarm page looks like. There's a whole networking section. Underneath that, there's perfSONAR, and we've developed a number of different alerts that you can subscribe to. Mainly, to date, we've looked at packet loss and throughput. We're adding additional alarms on traceroute, and we're trying to do some higher level alarms as well. We also have PS Dash, which is really a user dashboard to explore the analyzed and ranked and summarized perfSONAR data. Gives you a map. You can click on the individual dots. You get graphs. You can see certain types of ranked problems on the various tabs in the application. So next steps for us. We have a lot more to do regarding network topology. Of course, what really matters when you have a problem is what the path is that you're seeing the problem on. So because routes do change, because things happen in time, there's a challenge with network topology. Do we understand what the routes are? Do we understand how they correlate with other routes, et cetera? We also need some site-specific monitoring. perfSONAR is great for running these tests, but we also need information from the sites that are participating in our infrastructure. A simple one would be, what is your input and output bandwidth for your site as a whole? Just to give us some real-time information about how it's behaving. Maybe also an opportunity to describe the network in more detail would be nice. So we're trying to provide an infrastructure that allows sites to post that information and make it accessible. We've been trying to slowly translate the pipeline that we have. Currently, most of the data is pulled. We go out to Esmond and we grab the data and pull it into a central pipeline, get it out to Elasticsearch or other locations. We've created now the ability to actually securely push the data, and that's actually built into PWA. So we have a plugin that we can put in that will give the site the credential it needs to write directly to the RabbitMQ bus. We would like some new tests for flow labels. We're doing some traffic marking work, and we'd like to verify that those can get through end to end. And then, of course, just broadening our engagement with the global research community. If you have additional ideas or suggestions, please let us know. We're very interested in taking all the valuable data we have and doing cool stuff with it. So to summarize, we've got this collaboration of OSG, WLCG, and various research projects that have created this reliable, extensible infrastructure that looks at our networks and tries to give us some analytics and visualization. We've been making progress in these tools, but of course, we need to continue to monitor and maintain what we've built. And that's a big challenge when you have a globally distributed infrastructure. And we have a number of challenges that are remaining. Really, the meta challenge at the high level is making effective insights available for everybody to easily use the data that we're collecting. So I will stop there and see what questions or comments people have. Thanks.
All right, I'm not seeing any questions at the moment in chat, but I'll give people a second to type. While they do that, yeah, thank you very much, Shawn, for that, and that's a good info there.